Hi, my name is Nelvia Benedict from Group Oreo. Today I will explain to you about data transmission in data communication and NUKIT. Data transmission is the transfer of data over a point-to-point or point-to-multipoint communication. Example of such channels are copper, wire, optical fiber, wireless communication channels, storage media, and buses. The data are represented as the electromagnetic signal such as electrical voltage, radio wave, microwave, or infrared signal. Analog transmission is a transmission method of conveying voice, data, image, signal, or video information using a continuous signal with varies in amplitude, phase, or some other property in proportion to that of a variable. The messages are either represented by a sequence of pulses by means of line code, or by limited set of continuously varying waveforms using a digital modulation method. The passband modulation and corresponding demodulation is carried out by modem equipment. According to the most common definition of the digital signal, both baseband or passband signal representing bit streams are considered as digital transmission, while an alternative definition only considers the baseband signal as digital.
Hi, my name is Nabila Ika. Digital to digital conversion. In this section, we can see how we can represent digital data by using digital signal. The conversion involves three techniques. It's line coding, block coding, scrambling.
Line coding is always needed. Block coding and scrambling may or may not be needed.
Topic discussed in this section is line coding schemes, block coding, scrambling. Line coding is process of converting digital data to digital signal. Line coding convert a sequence of bits to a digital signal. At the sender, digital data are encoded into a digital signal. At the receiver, the digital data are recreated by decoding the digital signal. Line coding and decoding. Line coding characteristic. Signal element versus data element. A data element is the smallest entity that can represent a piece of information. This is the bit. Signal element is the shortest unit timewise of a digital signal. In digital data communication, a signal element carries data element. In other words, data elements are what we need to send. Signal elements are what we can send. Data elements are being carried. Signal elements are the carriers. Signal element versus data element. Signal rate versus data rate. The data defines the number of data elements bit sent in 1 second. The unit is bit per second. The signal rate is the number of signal elements sent in 1 second. The unit is bound. The data rate is sometimes called the bit rate. The signal rate is sometimes called the pulse rate, the modulation rate, or the bounce rate. One goal in the data communication is to increase the data rate while decrease the signal rate. Increasing the data rate increase the speed of transmission. Decrease the signal rate decrease the bandwidth requirement. We can formulate the relationship between data rate and signal rate as where n is the data rate, c is case factor which varies for each case, s is the number of signal element, r is previous defined factor. Baseline wandering. In decoding a digital signal, the receiver calculates a running average of the received signal power. The average is called the baseline. In incoming signal power is evaluated against the baseline to determine the value of data element. A long string of 0 second or 1 second can cause a
Drift.
in the baseline and make it difficult for the retriever to decode correctly. A good line coding scheme need to prevent baseline wandering. DC component. When the voltage level in the digital signal is constant for a while, the spectrum create very low frequency. This around 0, called DC, direct current component. DC component present problem for a system that cannot pass low frequency or a system that uses electrical coupling via a transformer. For example, a telephone line cannot pass frequency below
200 Hz.
Self-synchronization to correctly interpret the signal retrieved from the sender. The receiver's bit interval must correspond exactly to the sender's bit interval. If the receiver clock is faster or slower, the bits interval are not matched, and the receiver might misinterpret the signal. A self-synchronizing digital signal includes time information in the data being transmitted. This can be achieved if there are transition in the signal that alert the receiver to the beginning, middle and end of pulse. If the receiver clock is out synchronization, this point can reset the clock.
Effect of lack of synchronization.
Hi, my name is Faris and today I will be talking about analog to digital conversion. We know that a digital signal is superior to an analog signal. The tendency today is to change an analog signal to digital signal. In this section, we describe two techniques, postcode modulation and delta modulation. Here are the components of PCM encoder.
Yeah.
While these are the three different sampling methods for PCM. This is the Nyquist sampling rate for low pass and band pass signals, while this is the quantization and encoding of a sample signal. What is the SNR dB in the example of figure above? We can use the formula to find the quantization. We have 8 levels and 3 bits per sample. So the answer is 19.82 dB. These are the components of a PCM decoder, while these are the process of delta modulation. These are the delta modulation components, while these are the delta demodulation components.
I am Mustaqim and I'm going to explain about transmission mode. Transmission mode refer to the mechanism of transferring of data between two devices connected over a network. It is also called communication mode. This mode directs the direction of flow of information. There are 3 types of transmission modes. They are simplex mode, half duplex mode, full duplex mode. This is the example of transmission mode. First is simplex mode. In this type of transmission mode, data can be sent only in one direction. Communication is unidirectional, so we cannot send a message back to the sender. Unidirectional communication is done in simplex system where we just need to send a command or signal and do not expect any response back. Example of simple mode are loudspeaker, television broadcasting, television and remote, keyboard and monitor, etc. This is direction of the data. Second, in half duplex mode, half duplex data transmission means that data can be transmitted in both directions on a signal carrier but not at the same time. For example, on a local area network using a technology that has half duplex transmission, One workstation can send data on the line and then immediately receive data on the line from the same direction in which data was just transmitted. Hence, half-duplex transmission implies a bidirectional line so that can carry data in both directions, but data can be sent in only one direction at a time. Example of half-duplex is walkie-talkie, in which message is sent one at a time but messages are sent in both the direction. This is example of the direction. Lastly is full duplex mode. In full duplex system, we can send data in both the direction as it is bidirectional at the same time. In other words, data can be sent in both directions simultaneously. Example of full duplex is a telephone network in which there is communication between two persons by a telephone line, using which both can talk and listen at the same time. This is an example of the direction of data in full duplex. That's all with our group, and thank you.